Next, what we want to do is we want to talk about the behavior of RIP across certain types of interfaces. Specifically, I'm talking about serial interfaces, which could or could not operate as on-demand style circuits. Now, in our topology, on our link between R22 and R2 and R22 and R3, we have serial interfaces, specifically S20 and S21 on both ends of our link. Now, what I may want to do is I may want to make a modification to the behavior of my RIP protocol such that I do not want to constantly flood updates across these links. In other words, what I want to do is I want to do away with the every 30 seconds of sending information across these links, especially if these links were possibly slow or if these links were very, very reliable and I could push everything out. So what I want to do is and this dates back to the old days of ISDN, believe it or not. ISDN circuits, we used to have a ISDN called a BRI, a basic rate interface, and it normally, every time you would dial or use that link, you would get charged for it. The problem is that a lot of organizations began running RIP across these interfaces and across these services, and every 30 seconds it would force the link to come up, and what would end up happening is the company at the end of the month would get these shoe boxes of bills that were going to be for several $1,000s a month for this 128K circuit that they had through the phone company, through this leased line. Now, admittedly, all of that stuff is long behind us. However, it is important for us to understand on these serial links, we still have this capability. And what I'm making reference to is something referred to as RIP triggered. Let me take my big old head out of the way. RIP triggered operations. So triggered operations means only send updates during changes. So if something happens to the topology, that's when I want you to send that information. So we still want to make certain we converge across these links, but we don't want to burden the links with all of these updates. Now, the syntax is extremely simple. It needs to be configured on both ends of our links. But what I want to do is I want to entertain the changes that take place. And first and foremost, what I want to do is I'm going to go to R22 to the data center router. And what I'm going to do is I'm going to type show IP RIP database. And what we're going to see here is we're going to see information associated with every prefix that we've learned with regard to RIP. Now, what I want to do is I want you to realize everything that we're going to be learning is going to be learned through either serial 20 or serial 21, because those are the only interfaces that we have that are connected to the rest of our network. Now, what I'm going to do is I'm going to make a modification change. I'm going to go under first serial 2/0, and I'm going to say IP RIP triggered. Then I'm going to go up to R2, interface S20, and say IP RIP triggered. Now what I want to do is I want to go back to R22. Show IP route, RIP. Now notice that we still are operational, so we're still learning prefixes from 2.1 and from 2.0. Let's see if any of our timers are getting freaky on us. Nope, nothing's upset, nothing's going on. I still have a static route here though. Let me take a look at that while this is percolating. I just want to make sure of what's going on. And I got bitten by another issue. I executed the no default information originate route map command, and all it did was remove the route map. Route-map. It just took that off. It did not take off the default information originate command. So what I want to do is I want to make sure that that's gone. So what I'll do is I'll go under here and take that out just to eliminate that whole requirement. So no default information originate. Get rid of that. That should now be gone. Let's go back over to R22. Let's see if any of our prefixes are now missing. Show IP route. Gateway of last resort is now not set, but that's what I wanted. And I'm still learning about all of my prefixes via serial 2 and serial 21 and serial 20. But what I want to do is I want to take a look at the output of my show IP RIP database command again now. And what I want you to see is everything that we're learning across serial 2/0 now has a designation that says permanent. It's permanent because it's going to not require any information to be sent across this link to R22 by virtue of the fact that we've created this RIP triggered configuration. Let's make the marrying configuration on 2.1 on R22 and on R3. So interface serial 2.1 IP RIP triggered. Go over to R2. Interface serial 2.1 IP RIP triggered. Now when I go back over to R22, what I'm going to find is now I'll have more entries, show IP RIP database. I should see more entries in here with regard to triggered permanent prefixes. Let's see. Show run interface S20 RIP triggered, S21 RIP triggered, show serial 2.1 RIP triggered. No, that's 2.0. To show run interface S20. There it is, RIP triggered. Let's see if it's here on 3. Do show run interface S21, and it's not there. So here's where I need to make the change on R3. So interface serial 2.1 IP RIP triggered. Remember, it needs to be configured on both sides of the link. Now let's go over to R22, show IP RIP database. Okay, now we see that everything is listed as permanent that we're learning on each of these interfaces and what these triggered values are. So the last thing before we wrap up this part of our presentation is what I'm going to do is I want to execute a debug. So we'll say debug IP RIP, and we're going to hit enter, and we're just going to wait. I'm going to take myself off the screen while we're waiting, and let's see what's happening on this device, if anything. Show debug. Okay, let's see what we got going on here. Notice this is via the loopback. So we're sending an update out the loopback. Like I said, RIP can be pretty stupid. But what we're going to see here is that we're not going to send information out towards R2 and R3 on a regular basis like we have been, as a direct result of the fact that now the entries in our table are going to be permanent, and we're not going to send these updates. So this gives me the capability of restricting the amount of information I'm going to be exchanging across my link. It will not work on Ethernet connections. It will not work on a virtual internet Ethernet connection like a tunnel interface. But the main thing is that looking at this, we can see that we're not sending information out our physical links, our serial links, but we are still trying to communicate out of our loopback interfaces. So again, pretty interesting with regard to the way it's going to operate. But however, what happens if I change something? Well, I'll go over to R20, and I'm going to shut that interface down again. Interface S20. Well, no, let's just do this. Interface LO0. Shut. Now that's going to force a change. That's going to force a topological alteration in my infrastructure. So let's see what happens now. So we'll see if there's any change on R22. Well, notice right now we send a triggered update to 10.1.22 or 222.2 on serial 2, and what ends up happening here is that it's going to be a null update that we're sending, so it's being suppressed. So let's see what goes on. So do I have show IP route RIP? Do I have reachability to show IP route 172.16.20.20 or 20.0? It's not in my routing table. Can I ping it? 172.16.20.20. Won't be able to reach it. It was withdrawn, and we did only send an update across the link as a direct result of the fact that our topology changed. So what I'm going to do is I'm going to go back over here to R22, and I'm sorry, on R20, and I'm going to turn that interface back on. No shut. Cut back over to R22, and let's see what happens if we see anything with regard to an update coming across. We received a triggered update. Let me U-all this. And scroll up. We received a triggered update from R3. We received a triggered update from R2. And what ends up happening is it's the advertisement. And notice it required an acknowledgement. We sent acknowledgements back to ensure that we did everything that we were supposed to do. And what this is all in reference to is the fact that now we know that 172.16.20.0/24 has been learned, and it is actually 5 hops away from us right now. So again, it's pretty significant, definitely handy. Will you be asked about it in a lab? You could, you might not, but it's more important to me that you understand that it exists, and the capability is handy for being able to restrict the communications that we're going to be using to actually have our updates travel across our serial links. Triggered, RIP triggered is a handy tool, but again, it's only really going to fall into the germane of the test if you're specifically asked for it. RIP is not going to be a huge subject on the exam. However, I do want to make certain that we understand the protocol since it's on the blueprint. So with that said, I'll see you guys in the next video. Talk to you there.